Hey there. So this one, I'm about to do some modifications before designing a BK suction socket. So I just wanted to compare. I'm working on seeing how the inside of a cast, which is that, compares with the scan of a plaster model, seeing how close they are, and then working on getting to a point where I'm confident modifying from the inside of a cast so I no longer need to pour the plaster model. I still want to take the cast so that I can get the shapes and the markings that I want. Things like the contours on the medial and lateral sides of the tibia, doing some indenting with my fingers above the condyles, marking out all the bones. I still want to use this as my starting point for a socket. I don't want to just scan a limb, but I want to be able to just take the scan from a cast and cut out the plaster so that I can save that step from a sustainability and cost saving standpoint. So I'm just going to go through here and just do the job and kind of narrate as I do. First thing I always do is work on just cleaning up, getting rid of all this stuff on the outside. So I'm just going to use the select tool and just go around here and delete that in sections. And I'm really just trying to make a clean break from the inside of the socket, or the cast in this case, to the outside. And then what I can do is select that, hit I for inverse, and delete all of that at once. Now the rest of this, what we can do is double click and control and roll down and just really quickly get rid of the rest of that, because none of that's really going to be necessary. That top couple millimeters won't matter for where we're going next. You can even do something like that. And then if there's a high point, get rid of that first and then roll back up. So like here. And one more time, we'll hit I, invert, and delete. Then I'll do Control A, select all, and flip normals. So from here, let's just verify a couple things real quick. Analysis units, that all looks like we're in the right ballpark in millimeters. So this is correctly sized, which I know my models coming out of Scandy are, because I export them the same way every time. And then I'll transform and put this in position. I'll take snap off, use world, and I'm getting better at using some of these tools here, which you might see during this. Just figuring out what all the different stuff does over time and continuing to improve with those. And I'll just move this to the center of the screen. Good. And I like that one. And now I'll do the same. I'm going to clean up the scan of the plaster model. This one was weird. It came in with this kind of inner shell to it. I don't know why. It doesn't seem to have affected the outside, but I tried to scan this one multiple times and I kept getting that. So that's easy enough to delete. Wasn't really worried about it. What I want to do is actually line these up. So I'll turn that one back on. And I want to see how these compare. So I'm going to aim to get them in the same exact spot using those markings. And this is never going to be perfect because the scans are going to be different. So So I just try to pick a couple key things to line up. So I'll follow the general contours you can see like on the posterior side here. I'll look to make sure those are at the same angle. You can see here this marking tracks right in line, so I'm pretty happy with that. Come to the front. The patella lines up. And if you watch this marking on the lateral side, you can see it kind of fades in and out. So about there is where everything looks complete if I look at both models as one continuous piece. So that's where I think everything's pretty good. I'm going to hit accept and save there. And now if I wanted to move and look at more things, I can. And because I already accepted that, I can come back to that spot by hitting Control Z or cancel. So I think that's pretty good. Let's change the view. It's sometimes easier to see how things look this way. You can see, obviously, we've got the model of the inside of the cast is a little more shaded to the medial side, the plaster positive a little more to the lateral. So this could be something that can be transformed out if we were to maybe tilt that and slide it. We can kind of find a happy medium there, where the goal is what I'm looking for is to basically get to these to a point where things just blend in and out of each other like this. There's no part that's obviously one or the other. So that's pretty good overall. Looking at that, it all still looks right as far as the markings go. So I'm going to say that that's probably my best spot. And if we want to see how much variation there is, we can watch here. You can watch the fib head. The plaster positive is bigger, so it's the darker one, so it's bigger there, which is not unexpected. When you scan the inside of a cast, what we expect is that contours are going to get a little bit washed out. So if you have a fib head or a contour, it might bring that in. It's probably going to bring a lot of times it'll bring the distal end up. In this case, it doesn't really look like that happened. You can see my thumb indentations on the sides of the patella tendon line up pretty closely, so I think we're in the right place. Really looking at that, I'm not too worried about anything I see there. That to me looks like a scan of the inside of the cast that I can definitely work with. Being that this is a test socket, I'm going to build up the fib head a little bit anyways. I wouldn't always do that on a plaster model, but on my digital ones I do, just because I know that's getting washed out. And that's really the thing, is just figuring out how scans work and what happens on them, and then accounting for that. And you might have to change what you do, but that is part of the process of learning how to do this. So I'm going to duplicate the inside and start doing some modifications. The first thing is the distal end's a little rough. So I'm going to select all that and kind of just blend and smooth those areas out. And I approach this very much in an artistic way, just like I would if I was hand modifying plaster. A lot of what we do when we're modifying there doesn't have measurements or doesn't follow any sort of, you know, measurements or pattern there. Like we might start reducing off the distal end and not really know where we end up. So in that case, that's something I actually feel better about using CAD mods, because we can always compare back to exactly where we started and see what we had. And if we don't like something, we can go back in time and do it over again. So there's a lot of reasons to like doing CAD mods as long as you figure out what works for you. In this case, I had some pretty good compression already on the pre-tibials. I don't really feel like there's much to change there. If I look at these, my cast is a little bit washed out. So I'm going to take a little bit off on those, where maybe on a plaster model I wouldn't even touch those. I would just be happy with what I already had. But in this case, I'm going to take a little bit out and start my modifications there. I'm going to pull back from my bony edge actually. I'll blend up into that to get a good smooth transition. And what I'm going to do here is a deform soft transform. And thanks to a mod for pointing out, if we do snap on this, we can actually move in known amounts. And when you're holding the arrow, you can hit the up and down keys to change the snap amounts. So right now I'm in increments of 1.25 millimeters. I can go a little bit lower. So I'm only going to take these in 3/4 of a millimeter. You can see how much depth that actually is, and then we'll blend that out until the point where it pretty much hits the bony transition. And I'll do the same thing on the lateral side. Now, if this wasn't a particularly defined cast, I might go more. I might go 1.25 or 1.5 millimeters there. Sometimes it's just depending on who takes the cast and how aggressive they are with their hands, and you might need a different modification style, whether it's your cast or if you're working on someone else's. So we've got that. I'm going to blend out the contours here a little bit across the MPT. I'm not really trying to make a patella bar. I'm just trying to shape around the patella a little bit. So I want to basically blend this area down into my thumbprints. I'm going to start that one over, see what a different amount looks like. Go right there. And then sometimes I like to turn this off. I can get a better view without markings. I just want to blend all this together now and smooth everything out. And then I'll do the same on the patella. I'll just kind of clean this up. And the tibial tubercle, same thing. So that's a pretty prominent tibial tubercle. That's because I actually took this cast with a panel. So I did like a 2-stage cast. I did a plaster panel with the knee bent to 90. That went around here and captured that tibial tubercle during flexion of the knee, which I think is really important. It also helped build out the shape of the condyles and build that flexion into the socket. And then I did a wrap over top with fiberglass, and I actually did the contouring in that fiberglass wrap. So it's a lot like a harmony casting, except just modified for the materials that I like to use in the process I'm working with now. I'm actually going to define this just a little bit more. Start kind of coming up the sides with it. We're going to pull that in just a little bit here. I'll show you if you go world, it'll pull directly on that axis. If you go local, it'll kind of go up and in. So I'm actually going to go world and pull that straight in. And you could then do things like tilting it and build it in that way. In this case, I think I'm just going to pull straight in and maybe come down a little bit so I don't get up into the patella too high. And then I'll blend all that out one more time. And I'm going to come down a little bit more when I do that. So that's a shape that I like. Next thing, I'm going to come up top. I'm going to clean up the top and extend this up. So I'm going to do sculpt, robust, smooth, turn that strength up, and just clean up this edge, get rid of all the jagged stuff. And then I will double click, select the ring, bring that down a little bit. And what I'm trying to do is just give myself more room. This would be like putting tape on the cast before pulling it, or before pouring it, sorry. And I will do modify, smooth boundary. And then I'll extrude that just straight up, so in the y-axis. And a quick plane cut. I just leave the top open, no fill. And that's just going to give me room to build in my contouring around the condyles. Another thing you can do here at this point is just blend out this transition a little bit. So you can barely see the mark here. Might have been better on the positive. Let's see. Yeah, so that's the top edge of the condyle. So I want to cut in a little bit above those. So we're going to come up here. Let's just W for wireframe, just seeing what that looks like. And I'm going to transform that. What I want to do here is actually tilt this, so I don't really want to cut into the top of the condyle. So what I've been doing is snap and I'm going to go about 2.5 here, and then I'm going to tilt until that pretty much comes back out, and I will tilt that direction also to keep that even. And then when I blend from there, it's going to cut in a little higher up. And same on the medial side. Probably don't need to go that high. Okay. Start to see that shape coming together there. Just going to blend out some of those transition points. And then I'm going to come to the back side. Well, actually, let's do the fib head first. So 3 millimeters is 1/8 of an inch. I'm going to go a little more because I think that got washed out a bit. Between the cast and the model. Blend that, and then what I'm going to do is blend those edges a little more. But I'm actually going to leave the apex unselected so that I don't affect that height at all. And we'll do a smooth here. And you might find that a different level of constraint rings gives you a better shape. And then I'm going to do it one more time. Slightly bigger. Okay. And now let's go to the posterior and do sort of our last bit of shaping here. I think I said medial and lateral reversed on these previously, but no big deal. We're going to come here. I'm going to come up close to that previous contour. My lateral trim lines are a little bit higher than my medial trim lines, so I'm going to stay down lower than I think they're going to be because I want to blend this up as well. I don't want to get all the way to the distal end either. So I always leave myself a little bit of room to blend these transitions in. And soft transform. I don't need a whole lot here, I've found. That should be good. And then as we blend this out, you'll see we start to get a little bit of that flare up into our trim lines there too. All right, so those are my general modifications. You can see the model is a little bit rough. I'm going to do edit, duplicate again, Control A, and smooth that. And let's just get a look at what it takes to start smoothing that out. So quite a bit there. So I'm actually going to remesh this for a little bit easier smoothing. We'll do an adaptive reduce. That should be a pretty good size there. And now this should smooth out much easier. That looks good. So that'll be the modifications for this test socket. If we flip back, you can see how we are compared to our lines in our map here. I came a little bit. I'm gonna clean up that contouring just a little bit on the fib head there. I think that marking was a little high, just knowing fib head's slightly at or below the tubercle. I think the apex isn't bad. I just want to blend that up a little bit. Otherwise, I like this. I think everything looks good there. Compared to the original inside of the cast, you can see we're bigger at fib head. We're about even across the tibia, across the condyles, which I didn't want to change. So that's pretty good. We're smaller through all the soft tissue. And I'm actually going to do a little bit of a tibia buildup here too. He has a bit of a callus or some old skin breakdown there from his old prosthesis that he had. So I'm also going to build him a cushioned flexible inner as I make this one. But let's finish up these last couple little things here. We'll do a select. Let's pull out this area just above that apex a little bit. I'm going to give it a little bit of a tilt. To blend that in a little better. And we'll select and smooth that. Let's pull out the distal tib a little bit. I want this more so to be a downward, create a little pocket downwards, in addition to coming out just a little bit there. And we'll smooth that out. For that last smooth, I like to just do the default here, smoothing scale 4, constraint ring 3, just to blend out any lines that I had created by doing modifications or any adjustments. Now when we compare to that, you can see we're definitely bigger on the distal tib. We've got a little relief there. We've got some fib head relief built in compared to our plaster model. Let's see where we're at. Yeah, so same thing, even bigger than the plaster, so we've got that built up. Like I said, on a plaster model, I might not have even touched the fib head on him, so that'll be pretty good there. And it's a test socket, so we'll see where things line up. It's an easy heat modification to adjust some of that if needed. So that's the modifications. From there, we'll design and 3D print a socket for this one.